Hi everybody, it's Emily here, and today is day 84 of the Odin project. Today I started and completed my linked list project for the JavaScript course, so I'm going to do a walkthrough of my code to show you exactly how I completed this project. Now, if you aren't familiar with what a linked list is, it's a data structure comprised of individual nodes, and each node contains data and then a reference point to the next node in the list. The start of a linked list is denoted by a head reference, and then the final item in a linked list always contains a reference to null being that last part of the list. Now, linked lists are a little bit different from arrays because you can add and delete elements more dynamically. Arrays are sort of stuck together, and when you add and remove elements, then you have to reorder the indices, because arrays by nature have set indices for each element, versus linked lists don't actually have indices. Each individual node only knows its own data and knows who should be next in line of the linked list. And so to add and remove nodes, all you have to do is just change the reference to whatever part of the list is next. So the task for the Odin project is to create two class or factory functions, one which creates a linked list and one which creates nodes. Now, I chose to use factory functions just because I enjoy writing them more. And I started by creating my node factory function. So if you'll see here on the right-hand side of my screen, I have const node factory, and then my input is a value, and then if a value is provided, then I set that value equal to value, and if a value is not provided, then my default value is null, and then next is going to be that next reference pointing toward whatever should be next in the list, and the default value for that is null as well. This factory function returns a new node object which contains the value and then the next reference. Now, the next part of this project is creating the linked list factory. I actually spent a good deal of my morning just stuck at the beginning of this factory function. I understood all of the linked list assignments and I understood the concept of linked list, but I had a hard time translating it into code at the start of this project. Once I did a little bit more trial and error and I did a little bit more researching on other resources about linked lists, I was able to start making some more connections. And then once I got a handle on it in the beginning, then the whole rest of the project just kind of wrote itself. It was very natural, like once you get a hang of it. So to start my linked list factory, I set my head reference equal to null because I don't have a linked list yet. And then I set the length of my linked list equal to 0. And I will be manipulating that as I apply different methods. So with this factory function, you are tasked with adding 10 different methods to the factory function. And these involve appending nodes to your list or prepending nodes to your list, having a method to be able to return the size of the linked list, being able to search for specific values in the linked list, etc. So I'll do a walkthrough of how I approached each of these methods in my own factory function. So to start, we have the method called append, which takes a value and it creates a new node and then appends that to the end of your node list. So I'm actually going to do a little bit of visuals here on the left-hand side of the screen. This is a website called Miro, which I actually used to use when I would make Kanban boards just for productivity. But I remembered that they had these sticky notes with little errors, sticky notes with little arrows. And I used this when I was learning about linked lists just for doing easy visualizations because you can quickly add and remove elements on here. So if you do want to use this, if you're learning about linked lists and you're also a visual learner, if you create an account with Miro, you can have 3 free boards and then it's pretty fun to play with. Okay, so for my append method, I start by creating a new node by calling the node factory, and the input is the value that will be assigned to that node. And I first check to see if the head reference for the linked list is null. If it is, that means we don't have a linked list yet. And so, hey, this new node that I'm creating is going to be the new head. Otherwise, we are going to create a variable called current, which I will denote with a little blue sticky note. And so current will also have a little reference point here to whatever comes next. Okay, so we're going to let current equal head. So the head node is node 1, so current is equal to this. Now, while current.next is not null, then we're going to do an action. So basically this means as long as whatever comes next, whatever current is pointing to, is not null, then we will do what we have here in the brackets, which is current equals current.next, which basically just means, okay, we're just going to move to the next item in the linked list. And we're going to keep doing this until, oh, okay, the next item here is null. So we break out of this condition, and then current.next is going to equal node, which is our brand new node. This will be our new node. And so current is referencing node 3. And so current.next is going to instead reference new node. And I'm going to go ahead and just delete this current. And as you remember with our node factory, the default next value for a new node is null automatically. And so here we have successfully appended a new node to the end of our linked list. And then the last step of this method is we have length plus plus. So remember we set our length equal to 0 in the beginning, and then every time we append a new node, we want to add 1 to the length. So this is just our own way of just keeping track of the length. As you'll see later, we'll be able to then return that length if we want to know how long our linked list is. Our next method is called prepend, and this one creates a new node and adds it to the start of the node list. And so this one's similar to the other one. We start by just creating a new node by calling the node factory function and passing in the specified value. We check to see if a head references null, and if it does, then that means there isn't a linked list yet. So whatever our new node is, that's going to be the head. Otherwise, if a head already exists, then we are going to go back to our current variable. Okay, so then I created our little current variable, and the current variable is going to be set to this head node. And then I'm going to make a little sticky note for our new node. And new node.next is going to reference current. So new node.next is going to reference node 1. And then head is going to equal our new node. Boom. So we can see here, and we can move this current variable out of the way, that we have effectively added a new node to the start of our linked list. And then again, we just update the length to show that we added a new node. Our next method is size, and by calling this method, you just return the length of the linked list. So it returns whatever the length is at that given time. The next method is called head node. This method will return the head node of the linked list. So first, I just do a check to see if a head even exists, and if it doesn't, then we give an error message that there is no head. Otherwise, we return the head variable. So that one's pretty straightforward. The next one is the tail method, which returns the final node in the list. And if you kind of notice a pattern in all these methods, to get to any point within the linked list, you have to go through the whole linked list. So unlike an array where you can just reference an index and just, grab an element right from the middle, with a linked list, you have to traverse the whole thing. And so to start this method, I again check if a linked list even exists, and if it doesn't, then we give an error message. Otherwise, big surprise, we set the current equal to the head node, and then while current.next is not equal to null, then current equals current.next. So we're going to keep traversing through the linked list until, current.next is equal to null. Then we return whatever current is. So we return node 3, which is the tail of the linked list. All right, so this next method is called @, and it takes an index and then it returns whatever node is located at that index. And again, linked lists don't actually have indices, so this is just our own definition of the indices for the linked list. So I start the method just by, again, checking if a head exists, which means does a linked list even exist? And if it doesn't, then I provide an error message. Otherwise, I set the current variable equal to the head of the linked list. And for this one, I create a for loop. So I set I equal to 0 as long as I is less than the index number, and I increase I by 1 each time. So essentially, I repeat whatever is within these brackets however many times the index is. So if the index is 2, then I repeat it twice. And so the idea is I'm going to traverse the linked list however many times the index is, and then wherever I end up, that's going to be the node that I return. So first, I actually just check to make sure that the index is within the node list. So if at any time while I'm traversing the list, the current.next is equal to null, then I return that an item at that index does not exist because the index is larger than the size of my linked list. Otherwise, wherever I end up, once I finish completing those iterations, that is the current node that I'm going to return. So for example, if the index is 2, then I start with my current variable set to the head node, and then I would complete this 1, 2 times, and then return node 3. And so my indices are 0, 1, 2. And the way that I'm traversing, again, I do the current equals current.next. That's pretty much the pattern that you'll see for pretty much all of these methods that traverse through the linked list. The next method is pop, and this one removes the final node from the linked list. So again, I start this method by checking if a linked list even exists, and if it does, then I set current equal to the head node, and while current.next is not equal to null, so this one we switch things up a little bit. So I'm actually going to throw another sticky on here, and this will represent current.next. Instead of just looking at current.next, we want to look 2 ahead. And so while current.next is not null, then we move forward 1, current equals current.next. So you'll see here when we're starting at the beginning, current.next is node 3, which is not null. And so we move forward 1. And once we get here, we do see that current.next is null. So we break out of this condition, and then we set current.next equal to null. So this one is current, and so instead of referencing node 3, we reference null, which essentially just cuts node 3 out of the linked list. And then we update the length to show that we removed a node from our list. Our next method is called contains, which takes a value and then it searches for that value in the linked list. And if the value is contained, then it returns true. Otherwise, if it is not included in the linked list, then it returns false. So I start this method by first checking to see if a linked list exists. And if it does, then I set current equal to the head node. And while current.next is not equal to null, we check to see if the value of this node matches the value that's input. And if it does, then we return true. But if it doesn't, then current equals current.next, which just means we move down the line to the next one. And we check to see if that value matches. And we keep going down the list until current.next equals null. And at that point, we break out of this condition. And then I added this other condition where once we get to the end, if current.value does not match the input value, then we can safely say that this linked list does not contain that value, return false. Otherwise, if the value of this current node does match the value input, then we return true. This next method is called find, and this takes a value, and again, it searches for the value within the linked list. And if the linked list does contain the value, then it returns the index of that node. And so first we check to see if a linked list even exists. And if it does, then we set the current equal to the head node. And then we also set index equal to 0. So we can use this for counting indexes or indices, because again, linked lists don't actually have indices. So while current.next does not equal null, we check to see if the value of the current node equals the input value. And if it does, then we return whatever index is at that time. And if it doesn't match, then we move to the next one in the list. So current equals current.next, and we update our index. So we add 1. And so this is just a way of counting how many nodes we're traversing as we are looking through our linked list. And then once we get to the end of the list and current.next does equal null, again, we check to see if there's a value match. If there is, then we return the index. If there is not, then we return that this value cannot be found. So our final method is called toString, and this returns a string representation of your linked list. So for this method, I'm actually going to pop over to our DevTools console. I dragged my index.html file into my browser so I can show you how to check this method. At the end of my code file, I have a variable called linked list, and this I just set equal to the linked list factory function. And so to create a little linked list, I just use my append method, and I added 4 different animals, so dog, cat, fish, and ferret, to our linked list. So that should be saved now. And to use the toString method, we first check to see if a linked list exists. And if it does, then we set current equal to head at the start of the linked list, and we create an empty string. And then we use the same method to traverse the linked list, where we check to see if current.next does not equal null. And as you visit each node, you basically just add whatever the value of that node is to the string. And then you move on to the next node. And finally, when you get to the end, then you'll break out of this condition and you add the value of the final node. And then you add a little arrow and type null to indicate the null reference at the end of the linked list. And then finally, you return the string. And so I'll show you here in the console. If we do linked list dot toString, oops, voila. Here we have a string representation of our linked list. So this is all that I have for the project right now. I probably will review my code again tomorrow to see if there's any areas that I can clean up. I think with my error handling, I might consolidate it a bit and create a small helper function for just relaying a general error message if a linked list doesn't exist yet. There's also some extra credit that the Odin project has for a few extra challenges you can do with the project. So I'll take a look at that as well and see if I'd like to incorporate that. But thank you so much for tuning in today. And I have a question for you guys. If you've ever used linked lists in your project before, or if you've seen them used in the real world, I'd love to hear about it if you want to put it down in the comments below. I think they're really interesting, and this is my first time working with them. So thank you again for tuning in. Be sure to hit the like button if you enjoy our updates, and hit the subscribe button if you'd like to follow along on our coding journey. And I hope you have a great day. I'll see you next time.